Well, now that everyone has managed to find the classroom, we can finally get started. No talking, and keep your eyes on the board. Today, we will talk about nuclear fallout and its effects on the environment. The consequences of the nuclear explosions changed our world and brought us here to Vault 101. Before we start talking about nuclear fallout, I want to show you what actually happened to the outside world many decades ago. It is very important for you to see the horror of nuclear weapons. Now that you have seen the video, we are going to discuss nuclear fallout and its effect on the environment. In general, nuclear fallout is the particles of matter in the air made radioactive by a nuclear explosion. Some of these particles fall in the immediate area and some get carried by upper winds many thousands of miles. Eventually they fall to the earth. Both local and worldwide fallout hazards of nuclear explosions depend on a variety of interacting factors: altitude and latitude of detonation, time of year, local weather conditions, weapon design, and explosive force. The rate of fallout largely depends on the altitude of the nuclear explosion and to a lesser extent on the magnitude of the explosion. If the explosion occurs in the air where it is unable to suck dirt particles from the ground, then the particles are lighter and take much longer to follow. If the blast is able to get particles from the ground, then they fall more quickly in the immediate area. Some nuclear weapon designs require the splitting of heavy elements like uranium and plutonium. For example, if a free neutron runs into a U-235 nucleus, the nucleus will absorb the neutron, become unstable and split immediately. The probability of a U-235 atom capturing a neutron as it passes by is high. In fact, as soon as the nucleus captures the neutron, it splits into two lighter atoms and throws off 2 or 3 new neutrons. The larger yield nuclear weapons derive a substantial part of their explosive force from the fusion of heavy forms of hydrogen, deuterium and tritium. Deuterium and tritium combine to make a helium atom, and neutron and energy, since there is virtually no limitation on the volume of fusion materials in a weapon, and the materials are less costly than fissionable materials. The fusion, thermonuclear, or hydrogen bomb brought a radical increase in the explosive power of weapons. In order to survive a nuclear attack, our ancestors had to follow certain instructions. The survivors of the nuclear attack sought protection in basements and shelters and kept emergency supplies. Unfortunately, not everyone was able to find good protection, even though some hid in natural terrain, cars, or open buildings. Some were exposed to radiation through the explosion and nuclear fallout. The results were immense. A factor which was critical in determining the hazard of radiation was the chemistry of the atoms. This determined whether they would be taken up by the body through respiration or the food cycle and incorporated into tissue. The risk of biological damage from the destructive ionizing radiation was multiplied. One of the most serious threats was cesium-137, a gamma emitter with a half-life of 30 years, and strontium-90. These isotopes were the major sources of radiation in the nuclear fallout, and since both isotopes parallel potassium and calcium chemistries respectively, they were readily taken into the blood of animals and humans and incorporated into bone tissue. Ionizing radiation by definition ionizes, that is, pushes an electron out of its orbit around an atomic nucleus, causing the formation of electrical charges on atoms or molecules. Altering chemical bonds may change composition or structure. Ionizing radiation is powerful enough to do this. For example, a typical ionization releases 6 to 7 times the energy needed to break the chemical bond between two carbon atoms. This ability to disrupt chemical bonds means that ionizing radiation focuses its impact in a very small but crucial area. In our case, all of these collisions and ionizations took place very quickly, in less than a second. It took much longer for the biological effects to become apparent. If the damage was sufficient to kill the cell, the effect became noticeable in hours or days. However, the effect of radiation is not always to kill the cell, but to alter its DNA code in a way that leaves the cell alive but with an error in the DNA blueprint. The effect of this mutation depended on the nature of the error and when it was read. Two important effects of radiation were cancer, which resulted from mutations in non-germ cells, termed somatic cells, and heritable changes, which resulted from mutations in germ cells. Those exposed to ionization radiation mutated. The offspring were born with an error in the DNA blueprint. After the war, the number of genetic defects increased and the quality of the human gene pool was reduced to some incalculable extent. Nowadays, mutants can be found outside the vault in the fields, abandoned buildings and subways.